June 30th, 1908, 7:17 a.m. A blinding light tears across the Siberian sky, brighter than the sun. Seconds later, an explosion with the force of 1,000 Hiroshima bombs levels 770 square miles of forest, killing an estimated 80 million trees instantly. But here's what makes this terrifying. There was no crater, no impact site, no meteorite fragments. The Tunguska Event remains the largest cosmic impact in recorded human history. An explosion so powerful it was detected by seismic stations across Europe and Asia, yet so mysterious that over a century later, we still can't explain exactly what happened. Was it a comet? An asteroid? A fragment of antimatter? A secret weapons test? Or something even more disturbing that governments have been hiding for over 100 years? By the end of this video, you'll understand why the Tunguska Event terrifies scientists more than any other cosmic phenomenon, why it could happen again at any moment above a major city, and why we're completely unprepared to stop it. But first, if mysteries involving cosmic threats and unexplained explosions fascinate you, hit that subscribe button. What you're about to learn will change how you look at the sky forever. The Tunguska River region of Siberia, 1908. This is one of the most remote and sparsely populated areas on Earth, endless forests of pine and larch trees stretching for thousands of miles, inhabited by scattered indigenous Evenki people and a handful of Russian settlers. On the morning of June 30th, the region was about to become ground zero for the most powerful natural explosion in modern history. At approximately 7:17 a.m. local time, eyewitnesses across a vast area of Siberia reported seeing a bright blue light streak across the sky, from the southeast to the northwest. The object was described as a cylindrical column of fire, so brilliant it was painful to look at directly. Semyon Semyonov, a trader located about 40 miles from the epicenter, gave this account. Suddenly in the north sky, the sky split in two and high above the forest, the whole northern part of the sky appeared covered with fire. At that moment, I felt great heat as if my shirt had caught fire. I wanted to pull off my shirt and throw it away, but at that moment the sky slammed shut and a great crash knocked me several feet from the porch. What Semyonov witnessed was an airburst, an explosion occurring several miles above the ground with devastating consequences below. The explosion occurred at approximately 3 to 6 miles altitude above the Tunguska region. The energy released was equivalent to 10 to 15 megatons of TNT, roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. The blast wave flattened an estimated 80 million trees in a radial pattern spanning 830 square miles. Trees at ground zero were left standing but stripped of their branches, like telephone poles. Further from the center, trees were knocked over in a perfect butterfly pattern that pointed directly back to the epicenter. But incredibly, there were no known human fatalities. The remoteness of the region meant that the blast zone contained only scattered reindeer herds and a few Evenki camps. The explosion occurred at just the right place and time to avoid mass casualties. If the event had occurred just 4 hours and 47 minutes later, the Earth's rotation would have positioned St. Petersburg, then the capital of Imperial Russia, directly under the blast zone. If you're already feeling the weight of how close humanity came to catastrophe, show some love with a like. This is just the beginning of how terrifying and mysterious the Tunguska Event really is. In the hours and days following the explosion, eyewitnesses across Siberia and Central Asia reported strange atmospheric phenomena that revealed just how massive the event had been. The shock wave from the explosion circled the Earth twice, detected by barographic stations in Britain. Seismographs across Europe and Asia recorded the event, initially mistaking it for a powerful earthquake. In England, atmospheric pressure instruments recorded unusual fluctuations for hours after the blast. But the most eerie phenomenon was the atmospheric glow that persisted for nights after the explosion. For 3 consecutive nights following June 30th, people across Europe and Western Russia reported that the night sky was so bright they could read newspapers at midnight without artificial light. This luminous phenomenon was caused by tiny particles ejected into the upper atmosphere by the explosion, scattering sunlight even after the sun had set below the horizon. The effect was visible as far away as London, over 3,000 miles from the blast site. Yet despite this global evidence of a massive event, the world barely noticed. The Tunguska region was so remote and communication so limited that news of the explosion didn't reach major population centers for days. And when it did, it was dismissed as exaggerated reports from superstitious peasants. But here's what makes the immediate aftermath so strange. Despite the massive explosion, there was no crater, no impact site, no obvious meteorite fragments. The ground at the epicenter showed blast damage and scorching, but no evidence of anything actually hitting the Earth. This wasn't supposed to be possible. Explosions of this magnitude should leave unmistakable geological evidence. A crater, shocked minerals, melted rock. But the Tunguska site showed none of these characteristics. The Imperial Russian government, dealing with political turmoil and the approaching collapse of the Tsarist regime, showed no interest in investigating the event. The remote location, combined with the lack of obvious human casualties, meant that Tunguska was essentially ignored by official authorities. It would be nearly 2 decades before anyone bothered to visit the site and document what had actually happened. And by then, crucial evidence may have already been lost or degraded. 1927. 19 years after the explosion, Soviet scientist Leonid Kulik finally organized the first scientific expedition to the Tunguska site. What he found would deepen the mystery rather than solve it. Kulik was a mineralogist who specialized in studying meteorites. He had heard stories about the Tunguska explosion and became convinced that a massive iron meteorite had struck Siberia, potentially the largest meteorite impact in recorded history. As Kulik's expedition approached the blast zone, they began to see evidence of the explosion's power. Trees were knocked down in perfectly radial patterns, all pointing away from a central location. The closer they got to the epicenter, the more severe the devastation became. But when they finally reached ground zero, Kulik was shocked. Instead of a massive crater, he found a region of dead trees still standing upright but stripped of all branches and bark. The forest looked like a graveyard of telephone poles. Kulik spent years searching for meteorite fragments or a crater, convinced that the explosion had been caused by an iron meteorite impact. He excavated dozens of small depressions, drained swamps, and analyzed soil samples. He found nothing. No crater, no meteorite fragments, no shocked quartz or other geological evidence of impact. The explosion had come from the sky, devastated hundreds of square miles of forest, and left behind virtually no physical trace of what had caused it. Kulik's failure to find concrete evidence led to decades of scientific controversy. Without meteorite fragments or a crater, how could scientists prove what had caused the explosion? Eyewitness accounts were inconsistent and sometimes contradictory. The physical evidence was ambiguous at best. Here's what I find most disturbing. The Tunguska event was witnessed by hundreds of people and detected by instruments worldwide. Yet the actual cause remained completely mysterious for decades. What does this say about our ability to understand cosmic threats? Drop your thoughts in the comments. Kulik made multiple expeditions to Tunguska throughout the 1930s, becoming obsessed with solving the mystery. He photographed the devastation, interviewed remaining eyewitnesses, and collected soil and tree samples. His work provided the foundation for all future Tunguska research. But Kulik died in 1942 as a prisoner of war during World War II, never having solved the mystery that consumed 2 decades of his life. The Tunguska event remained unexplained. It wasn't until the 1960s and 70s that scientists finally developed a theory that could explain the Tunguska event's strange characteristics. An airburst caused by a cosmic object exploding in the atmosphere before reaching the ground. The theory works like this. A comet or asteroid, likely 60 to 190 feet in diameter, entered Earth's atmosphere at tremendous speed, probably 30,000 to 40,000 miles per hour. As it descended through the increasingly dense atmosphere, The pressure and friction became extreme. At approximately 3 to 6 miles altitude, the stress exceeded the object's structural limits. It catastrophically disintegrated in a massive airburst explosion, releasing energy equivalent to 10 to 15 megatons of TNT. The airburst model perfectly explains Tunguska's strange features: the lack of a crater, the radial treefall pattern, the atmospheric phenomena, and the absence of large meteorite fragments. Computer simulations conducted by NASA and other scientific institutions have consistently reproduced the Tunguska blast pattern using airburst models. When you simulate a cosmic object exploding at 5 miles altitude with the right energy release, the resulting shock wave creates exactly the butterfly-shaped destruction pattern observed at Tunguska. In 2013, scientists analyzed microscopic spherules, tiny spheres of melted rock found in the Tunguska region. Chemical analysis showed these spherules had an extraterrestrial composition, matching the mineral signatures of carbonaceous chondrite meteorites. This provided the first concrete physical evidence linking the explosion to a cosmic object, even though large fragments were never found. The current scientific consensus is that Tunguska was caused by a stony asteroid or possibly a comet that exploded in the atmosphere. The object was likely relatively fragile, more like a pile of rubble held together by weak forces than a solid rock, which explains why it disintegrated so completely. But here's what makes this truly terrifying. Objects this size are incredibly difficult to detect. The asteroid that caused Tunguska wasn't visible until it was literally hours away from Earth. Even with modern telescopes and detection systems, we might have only days or hours of warning if a similar object was headed toward a populated area. And Tunguska-sized objects hit Earth approximately every 300 to 1,000 years. We're not talking about an ancient, once-in-an-epoch event. We're talking about a recurring cosmic threat that could devastate a major metropolitan area at any time. If the Tunguska event had occurred over Moscow, London, or New York, millions would have died instantly. The explosion would have leveled everything within a 20-mile radius, caused mass casualties over an even wider area, and potentially triggered global political crises if nations mistook it for a nuclear attack. Despite the scientific consensus, Tunguska has attracted decades of alternative theories, some plausible, others bordering on science fiction. But in the absence of definitive physical evidence, these theories have persisted. Theory 1. Nikola Tesla's death ray. In the early 1900s, inventor Nikola Tesla claimed to have developed a death ray, or teleforce weapon capable of transmitting enormous amounts of energy through the atmosphere to a distant target. Tesla enthusiasts point out that he had been conducting high-energy electrical experiments at his Wardenclyffe Tower facility in New York in the years leading up to 1908. They suggest that Tesla may have test-fired his device at a remote region of Siberia. The timing is intriguing. Tesla was indeed working on wireless energy transmission during this period. But the physics makes this theory virtually impossible. The energy required to cause the Tunguska explosion would have required power generation capabilities far beyond anything Tesla or anyone else possessed in 1908. No credible evidence supports the Tesla theory, but it persists because Tesla himself made extravagant claims about his invention's capabilities, and much of his late career research was poorly documented. Theory 2. Antimatter. In 1965, scientists Clyde Cowan, Willard Libby, and others proposed that Tunguska might have been caused by a small amount of antimatter entering Earth's atmosphere from space. When matter and antimatter come into contact, they annihilate each other in a perfect conversion of mass to energy, far more efficient than nuclear reactions. A few pounds of antimatter could theoretically produce an explosion the size of Tunguska. The antimatter theory would explain the lack of residual material and the pure energy release of the explosion. However, there's a major problem. We've never detected naturally occurring antimatter in space in quantities large enough to cause such an event. Modern physics considers this theory extremely unlikely, though not technically impossible. Theory 3. Black hole. Some physicists have speculated that Tunguska could have been caused by a microscopic black hole passing through Earth. A primordial black hole, a theoretical type of black hole created shortly after the Big Bang with the mass of a large asteroid but the physical size of an atom, could theoretically pass through Earth's atmosphere, causing an airburst-like explosion through gravitational effects. However, if a black hole had passed through Earth, it would have created a second explosion where it exited on the other side of the planet. No such exit event was detected, making this theory untenable. Theory 4. UFO or alien technology inevitably. UFO enthusiasts have proposed that Tunguska was caused by an alien spacecraft crashing or exploding in Earth's atmosphere. This theory gained some credibility when Soviet researchers in the 1960s claimed to have found unusual radioactivity levels and strange metallic fragments at the site. However, these claims were never independently verified, and the researchers' credibility was questionable. No credible evidence supports alien involvement, but the theory persists in popular culture, appearing in science fiction novels, television shows, and conspiracy theory websites. Here's my question for you. If the Tunguska event happened over a major city today, how quickly would conspiracy theories spread before scientists could even examine the evidence? Share your thoughts on how social media would react to a modern Tunguska in the comments. Since the 1990s, modern technology has allowed scientists to investigate the Tunguska event with unprecedented precision. Satellite imagery, computer simulations, genetic analysis, and advanced dating techniques have revealed new insights. In 2007, Italian scientists led by Luca Gasparini announced they might have found Lake Cecco, a small lake near the epicenter, to be an impact crater from a fragment of the Tunguska object. They claimed the lake's depth and shape were consistent with an impact crater, and sediment cores showed unusual layering from around 1908. However, other researchers disputed this finding. They argued that the lake existed before 1908 based on older maps and tree-ring evidence from surrounding forests. The controversy remains unresolved. In 2010, researchers conducted genetic analysis of tree growth rings from Tunguska forests. Trees that survived the blast showed unusual mutation rates in growth rings formed after 1908, consistent with exposure to extreme heat and pressure. This analysis allowed scientists to precisely map the explosion's effects and confirmed the airburst hypothesis. Trees at different distances from the epicenter showed damage patterns that matched computer simulations of a 5-mile altitude explosion. NASA's Ames Research Center has run sophisticated computer simulations of the Tunguska event using models originally developed for studying asteroid impacts. These simulations can recreate the explosion's effects with remarkable accuracy. The simulations revealed disturbing insights about how vulnerable we are to similar events. A Tunguska-sized object exploding over a modern city would cause catastrophic casualties even without a ground impact. The airburst itself would generate thermal radiation sufficient to ignite fires across a massive area. While the shock wave would level buildings and infrastructure. In 2013, the scientific community got a stark reminder of the Tunguska threat when the Chelyabinsk meteor exploded over Russia coincidentally, also in a remote region of Siberia. The Chelyabinsk meteor was much smaller than the Tunguska object, only about 65 feet in diameter compared to Tunguska's estimated 200 feet. Yet it still injured over 1,500 people when its shock wave shattered windows across the city of Chelyabinsk. The Chelyabinsk event provided real-world validation of the airburst theory. Scientists watched in real time as a cosmic object exploded in the atmosphere, causing the exact type of damage that Tunguska theories had predicted. Most disturbing of all, nobody saw Chelyabinsk coming. Despite all our telescopes and detection systems, the meteor was undetected until it entered the atmosphere. If it had been Tunguska-sized, we would have had no warning before millions of people were killed. The Tunguska event isn't just an interesting historical mystery, it's a warning about a very real, ongoing threat to human civilization that we're almost completely unprepared to defend against. NASA estimates there are approximately 25,000 near-Earth objects larger than 450 feet in diameter, objects large enough to cause regional devastation if they struck Earth. We've only discovered about 35% of them. Tunguska-sized objects are even more numerous and harder to detect. There could be hundreds of thousands of objects in the 60 to 200-foot size range that we haven't cataloged. Any one of them could cause a Tunguska-level disaster. The odds of a Tunguska-scale event occurring in any given year are relatively low, roughly 1 in 500 to 1 in 1,000. But over longer time frames, the probability approaches certainty. We can expect a Tunguska-scale event within the next few hundred years. The question isn't if another Tunguska will happen. The question is when and where. If a Tunguska event occurred over Manhattan, it would kill millions instantly. The blast would level buildings across the entire metropolitan area. Fires would spread uncontrollably. The economic damage would be measured in trillions of dollars. If it occurred over a nuclear-armed nation, there's a real risk that the explosion could be mistaken for a nuclear attack, potentially triggering retaliatory strikes before anyone realized what had actually happened. So what are we doing to prevent this? The uncomfortable answer is not nearly enough. NASA's Near-Earth Object Observations program is working to catalog potentially hazardous asteroids, but they focus primarily on objects larger than 450 feet, objects that would cause global, not regional, devastation. Tunguska-sized objects fall into a dangerous gap in our detection capabilities. They're small enough that we don't actively track most of them, but large enough to cause catastrophic damage to a metropolitan area. Several proposed deflection systems, kinetic impactors, gravity tractors, and even nuclear devices could theoretically divert a threatening asteroid. But these systems remain largely theoretical. We've never actually tested our ability to deflect a real asteroid threat. The truth is that if another Tunguska object was detected heading toward Earth tomorrow, we would have very limited options to prevent it. Depending on how much warning time we had, we might be able to evacuate the impact zone if we're lucky. But evacuating a major city with only days or hours of warning would be chaotic, potentially deadly, and might cause more harm than good if the prediction wasn't accurate. The Tunguska event taught us that cosmic impacts aren't just ancient history or distant theoretical threats. They're ongoing dangers that could devastate modern civilization at any moment. Despite over a century of research, the Tunguska event still holds mysteries that science hasn't fully resolved. Mystery 1. The exact composition. We still don't know with certainty whether the Tunguska object was a comet or an asteroid. This matters because it affects our ability to predict and prevent similar events. Comets and asteroids have different orbital characteristics and physical properties. Some evidence suggests a comet. The atmospheric glow following the explosion is consistent with cometary ice vaporizing in the upper atmosphere. But the microscopic spherules found at the site suggest a stony asteroid composition. Mystery 2. The precise trajectory. Eyewitness accounts of the object's flight path are contradictory. Some reported it moving from south to north, others from east to west. Computer simulations require precise trajectory data to accurately model the explosion, but we still don't have definitive information. Mystery 3. The lack of major fragments. While the airburst theory explains why there's no large crater, it's strange that no substantial fragments have ever been found. Even objects that explode in airbursts typically leave behind some larger pieces. The Chelyabinsk meteor, for example, left behind fragments weighing up to 1,400 pounds. The complete absence of major Tunguska fragments suggests the object was extremely fragile, perhaps a loosely bound collection of material rather than a solid body. But this raises questions about what other types of cosmic objects might threaten Earth that don't fit our standard models. Mystery 4. The unusual effects. Some Tunguska researchers have reported strange long-term effects in the blast zone, unusual plant growth, accelerated forest recovery, and anomalous radiation signatures. While most scientists dismiss these claims as misinterpretations or measurement errors, they persist in the research literature. Perhaps the most unsettling aspect of Tunguska is how much it exposes the limits of scientific certainty. We have sophisticated theories, computer models, and physical evidence, yet we still can't say with absolute certainty exactly what happened on that morning in June 1908. If we can't fully understand an event that was witnessed, documented, and extensively studied for over a century, how can we claim to understand or defend against future cosmic threats? The Tunguska Event remains a humbling reminder that the universe can unleash devastating forces without warning, and that human civilization exists on a far more precarious foundation than we like to admit. The Tunguska Event stands as one of the most powerful natural disasters in recorded history and one of the most important warnings we've ever received about cosmic threats to Earth. On June 30th, 1908, humanity got incredibly lucky. The explosion occurred over one of the most remote regions on Earth, at just the right time to avoid major population centers. Had it occurred a few hours later or in a different location, it could have killed millions and potentially changed the course of human history. But luck runs out. Somewhere in the solar system right now, there's an object with Earth's name on it. We might detect it years in advance, giving us time to mount a deflection mission. Or we might have